Assalamualaikum and hi. For the Data Science and Methodology Group project, our project would be titled the Heart Failure, Quick Analysis and Prediction. For this group project, we have 4 members. Me, Muhammad Firdaus Imran, Nur Balqis and Jennet is from Chemical Engineering, while Nur Shazwani is from Mechanical Engineering. This is the table of contents for today's presentation. I'll be explaining on the introduction and my friends will continue on the data evaluation and discussion as well as the conclusion. So heart failure and quick prediction, two different subjects that is very important to us humans. Heart failure, one of the heart problems that a human can experience, is very fatal and can eventually put a person to a very critical condition or even to death, as heart is one of the most important organs for humans to be able to stay alive and function well. And quick prediction is the ability to predict what may happen in the future. Hence, by relating these two subjects, we can know when the heart failure may happen, and we can prevent it and take faster action to prevent the heart failures from happening. Hence, we can save more human lives in the future. For the datasets used, we have smaller the scope of the conditions that would lead to the heart failure itself, as we wanted to be more accurate and precise on the prediction. There are 13 datasets. Firstly is the age. Second is the anemia, the condition of the humans, of the red blood cells in the human body. The creatinine phosphokinase, which is the stress on the muscle tissue of a human. You have the diabetes. The ejection fraction is the amount of blood pumped by the heart on each contraction. We have the high blood pressure, the amount of platelets, the serum creatinine and sodium, which is the amount of creatinine and sodium, the sex of the human, the smoking condition of them, whether they smoke or not, the time that they spend on these conditions, as well as the death event, whether the heart failures themselves can lead to death or not.
Hi, my name is Nur Balqis and I will be discussing about the data preparation of this project. As we have known, there are 13 variables with their own type in the raw data file. During the data preparation, we have identified there is no missing values and duplicate values in the raw data. Then we proceed to data processing, where we remove time variable as it was considered as irrelevant in our analysis. We also mutated certain variables into factor and integer types such as age, diabetes, and also sex. Also renamed the death event variable into death variable. All this preparation is done to ensure process data quality is improved and can be used for heart failure prediction and analysis. Based on the bar chart and the box plot generated from the simulation, we have identified the general factor that contributes towards death event of heart failure. Patients with high possibility of death are mostly old, male, non-anemic, non-diabetic, have a normal blood pressure and also a non-smoker. They also have a lower ejection fraction, low creatinine phosphokinase, low platelet counts, low sodium serum, and also have a high creatinine serum. The next is the correlation coefficients between variables, which each cell in the table shows the correlation between two variables. It is shown that sex and smoking have the highest correlation compared to the others. Also, we observe that serum creatinine and age has the highest correlation with that variable, indicating that it might be the main factors leading to a death event of heart failure.
Hello, so I'll proceed with the data evaluations. Linear regressions is defined as a models that the relationship between two variables by fitting a linear equation to observe data. However, for these models, we were doing for multiple regression model as we wanted to test for of the variables with that event variables. A multiple regression considers the effects of more than one explanatory variables on some outcomes of interest. Root mean square error for linear regressions is 0.3869. This indicates that it still considers small values and it is in the acceptables of range. The residual is the vertical distance between a data point and the regression line. Each data point has one residual. The training models and improving models having a good value of residuals. Next, multiple R square represent the proportions of the variance in the response variables of a regression models that can explain by the predictors variables. The value of multiple R square for training models and improving models is in the range of 0 to 1, so it is in an acceptable range. The dependent variables that show the lowest random number value is injection fractions, serum creatinine, and H variables, followed by serum sodium and creatinine phosphokinase. The first three variables will be used to evaluate and improve the models. Logistic regression is a statistical analysis method used to predict a data value based on period observation of a data set. The RMSE for logistic regressions is 0, that is mean no absolute good or bad threshold. The completion metrics of logistic regression models show that the true positive is 107 while true negative is 36, and the false positive is 34 and false negative is 47. The dependent variables that show the lowest random numbers value is age, serum injection fractions, and serum creatinine variables, followed by anemia and creatinine phosphokinase. The first three variables will be used to evaluate and improve the models.
Hello, I'm Shazwani Fatini. I will continue this presentation. Linear forest is a model made up of many decision trees. This model trains different sets of observation. To avoid overfitting of trees, pruning techniques have been done. The trees are splitting into 5 nodes. Thus, the maximum allowable number of nodes is also 5. Moreover, the final predictions made by the random forest are by averaging the predictions of each individual trees. In this model, the maximum number of trees is said to be 100 trees. From this confusion metric, it shows that 23 data is true positive while 142 data is true negative, resulted in 73.66% of overall model performance. The ability of model to select the correct predictions is 92.81%, which is quite high, and the ability to reject incorrect predictions is 32.4%. The p-value of this model is 0.047, which is lower than 0.05. This shows random forest model is statistically significant. As you can see, the high correlation to death predicted by this model are serum creatinine, followed by ejection fraction, and age. Lastly, Bayes' theorem is used to test the model. Bayes is one of classification technique that assume the independence among the predictors. By using this model, the root mean square error to predict the probability of heart failure death is 55.9%, which the spreadness of residual is quite high. Besides, the likelihood of death in testing dataset if all variables is equally likely to occur is 31.25%, which is lower than average of training dataset, which is 34.67%. From the confusion matrix, it shows that 23 data is true positive, while 143 data is true negative. Resultant overall performance of model is 74.11%. However, the model is statistically significant due to p-value is lower than 0.05.
After doing all the methods, the RMSE that we are looking into, whereas logistic regression is having 0 RMSE, followed by linear regressions model and Bayes. The dependent variables that can be used to evaluate and improve the models, which are serum creatinine, age, and injection fractions. The people are having abnormal range of serum creatinine, which is exceeds serum creatinine normal range in between 0.74 mg per liter, which is the minimum, until 1.35 mg per liter, which is the maximum. The amounts of creatinine in our blood should be relatively stable, and increased levels of creatinine may be a sign of poor kidney functions. However, for serum creatinine is reported as milligram of creatinine to a deciliters of blood, which is mg over dl, or micromoles of creatinine to a liter of blood. The older the age, the higher the chances to be dead. The injection fraction normal range is between 55 to 70%. The left ventricle is the heart main pumping chamber. It pumps oxygen-rich blood up into your body aorta to the rest of the body. A normal injection fraction is about 50 to 70 is according to the American Heart Associations. A borderline injection fraction can be ranged between 41 and 50%.
To summarize of heart failure analysis, three types of models are used, which are regression method, random forest, and Naive Bayes. The best model is logistic regression with minimum number of RMSE. Lastly, serum creatinine, age, and ejection fraction are the highest contributions that lead to death due to heart failure. Let's spread awareness by eat well, rest well, and normalize healthy lifestyle. I will end our presentation with enjoy our life and say no more to heart disease.